So I have this table of data and I want to know what kind of function will fit this data. So I notice that my inputs are counting by ones every time, which means that I can look at the differences, in other words, the slope of this curve, by subtracting the outputs. So for my first differences, I'm going to take this output minus that output. 4 minus negative 3 is the same as 4 plus 3, which is 7. 21 minus 4 is 17. 48 minus 21 is 27. 85 minus 48 is 37. And then I don't have any other output to subtract that, so I have this blank space here. These differences are not constant, which means that we do not have a linear table of data. So we need to look further. Let's go to the second differences. And we find the second differences the same way we did the first. We take these differences and subtract them. 17 minus 7 is 10. 27 minus 17 is 10. 37 minus 27 is 10. We see that we have constant second differences, which means that this is a quadratic table of data. Since we're writing the closed form for a quadratic, we're going to use f at x, or f at n in this case, is equal to a times n squared plus b times n plus c, where a, b, and c are numbers. The f at n represents the output, the n represents the input. To find a, we're going to let a be, or a will be, half of the number that we got for second differences. So half of 10, which is equal to 5. To get our c value, we're going to let n be 0. So if we let n be 0, then we have a times 0 squared plus b times 0 plus c. And we know that if we have an input of 0, that has to equal negative 3. Any number times 0 is just going to be 0. So this zeroes out. B times 0 is 0, and we get c equals negative 3. So now we know our a is 5, we know our c is negative 3, and we need to find b. So let's go to the second row of our table. We know that if we let n be 1 in our quadratic, then our output has to be 4. So we're going to use f at 1, which is going to be 5 times 1 squared, because remember we found a to be 5 right here, plus b, which is what we're looking for, times 1, because our input is 1, plus our c value, which we found to be negative 3, and when we do that, the output has to be 4. So 5 times negative 1 is just 5, b times 1 is just b, minus 3 is equal to 4. Combine your 5 and your minus 3, and we have b plus 2 is equal to 4. Subtract 2 from both sides, and b is equal to 4 minus 2, which is 2. So now we know our a is 5, our b is 2, and our c is negative 3, and our function looks like f at n is equal to 5 n squared plus 2n minus 3. And that's the closed form for that function.